Hey everyone and welcome back, and in today's video we'll be looking into something related to microservices. Now in the case of microservices world, when one service makes a call to another service using synchronous calls, there can be problems from the other service that will get propagated to your service. Now in order to protect your service from these cascading problems, there are two patterns that you can use in order to protect your service. Now the first one is the circuit breaker and the other one is the retry mechanism. So in today's video we'll be looking at how we can integrate Resilience4J, circuit breaker and retry mechanism and protect your service from cascading problems. So with this, let's get started. So let's go to first start.spring.io and I'm going to add the Resilience4J dependency. So we have this Spring Cloud circuit breaker dependency of Resilience4J. So I'm going to add this and then I'm going to give a group name and I'm going to call this service as client service. We'll be using Java 17 and let's generate this particular project. So now I have already created this particular project. So let's open this here. So as you can see, I have a controller, I have a service and this main Spring Boot application, right? Let's look at our service. So in this service, we have this fetch data function, which has this retry annotation on top of it. Now, what are we doing in this fetch data function is that we are making a REST call to a get endpoint for this particular URL that we have here. Now let's look at the retry annotation. So in this retry annotation, we have this my retry name that is given and we have a fallback method. Now this fallback method corresponds to this particular method here, which has a parameter for an exception. The idea is if the number of retries gets exhausted, then the fallback method would be called and it will return this fallback value. Now, this was for the particular service, right? Now let's call this particular service from a controller. So we have this simple controller here with a get mapping and I'm just making a call to this particular service calling the fetch data function. Now, let's put in some configuration properties for this retry mechanism. So for this, what are we going to do is we are going to go to this properties section. So in this properties here, if you see, you have this Resilience4J property here for the retry mechanism. Now here I'm creating an instance called as my retry, which actually corresponds to this particular name that I've given here. Now under this, what I'm specifying are some of these properties. Now I'm setting the max retry attempts as 3 times and I'm going to set the duration between the retries as 5 seconds. Then also I'm going to enable an exponential backoff. Now what is this exponential backoff? So exponential backoff is a way using which you can actually retry after an exponential amount of time. So here I've given an exponential backoff multiplier of 2. So how this is going to happen is, since I've given a wait of 5 seconds, the first retry will happen after 5 seconds, the second retry will happen after 10 seconds, the third retry will happen after 20 seconds, and the fourth retry will happen after 40 seconds. But here it's only just going to do the 3 retries. Along with this, I've set up the exceptions for which actually the retries should occur. So here I've said in case if I have the REST client exception, then I should do the particular retry. But in case if I get an ignore exception, then it should be ignored. So basically the retry would not happen if this particular exception was being thrown by the fetch data function. Now, as we know that the retry that is provided from Resilience4J is actually based on Spring AOP mechanism. So let's go to this particular POM file here. So from our dependency, we added this circuit breaker Resilience4J. But along with this, we would need this Spring aspects also. So this Spring aspect dependency is required so that the retry annotation that we have in the service here invokes the particular aspect that handles the particular retry. So that's the reason we have to make sure that in our POM, we have this particular dependency. Now the web dependency here that is present is only required for the controller. That's it. With this, now let's start the particular application. So let's go here and start the application. So as you can see, our application has started here, right? Now what I'm going to do is I'm going to make a call to the service. So when I make this particular call, as you can see here, it's actually making a call to the particular second service, right? So it has tried first, it has tried for the second time, and it has tried for the third time and it still failed. So if you see here, this is at 21, this was at 0.5 seconds, and this happened at 15 seconds. So there's a difference of 5 seconds here, and there's a difference of 10 seconds here. And we got the fallback value here. Now this was because of the exponential backoff, right? Now this was related to how you can integrate a retry mechanism. You have this yet another concept called as a circuit breaker. So for this, what I'm going to do, I'm going to add a circuit breaker here. Now in this circuit breaker, I'm going to give it a name called as my circuit breaker, and I'm going to give it the same fallback method that we have here. Now, along with this, what I'm going to do is I'm going to remove the fallback method that we had for the retry mechanism. Why? Because the idea is that when I'm trying to request a particular service, I will allow the retries to happen, and if the retries fail, then it should be handled by the circuit breaker. Now for this particular circuit breaker, I need to add some particular configurations, right? So let's go to the properties file. Now in the properties file, I'm going to paste this particular properties here. What properties I pasted here is a circuit breaker property, which has a my circuit breaker, and we have these properties. Now, as of now, I will comment this property. I will tell why exactly this particular property is required, but later. So now let's concentrate on the circuit breaker properties. So what are the circuit breaker properties that I've set here? Is first thing is that the sliding window type is going to be count based. Now here, what is this sliding window? So this is a window of number of events for which I'm going to check if the particular circuit breaker has to be in the closed state or in the open state. Now what does a closed state means? It means that the circuit breaker is now not activated. That means we can make a call to the external service. But if it's in the open state, that means that the circuit breaker is been activated and no calls would be made to the external service. Now since we are using the count based here, I'm setting the sliding window count size as 5. This means that for 5 events, I will evaluate if the circuit breaker has to go to the close or the open state. Along with this, I'm going to set the minimum number of calls. So this is the minimum number of calls so that it can activate checking of the particular sliding window. Next, here I'm going to set 2 thresholds here. One is the slow call rate threshold, which has to be 60% for the circuit breaker to go into the open state. And similarly for the failure rate, I'm going to set it as 60%. Now the slow call duration threshold is set to 10 seconds here. Now this is mainly to switch between open and closed, right? Now there is an intermediate state called as a half open state. So now the half open state is a particular state through which it's like an evaluation state to determine whether the circuit breaker has to move to either the closed state or to the open state. So here I'm setting the permitted number of calls in the half open state that I'm setting here as 3. So in the window of now 3 calls, when it's in the half open state, 2 of the calls pass, then the transition goes to a closed state. If 2 of the calls fail, then it will move back to the open state. Now with this, what I'm going to do is I'm going to restart this particular application. So the application has now started. So what I'm going to do is make a call to this particular service here. So as you can see, it actually just made one call and immediately returned me the fallback value. So why was this actually? The reason is, let me go to the service pack again. So what happened here is that the circuit breaker was the first one to handle the exception that was thrown from this particular call here. And hence what happened is it directly went to the fallback value here, and then the retry took place. Now why is this? Now in Resilience4J, there are many other aspects such as bulkhead, there is also rate limiting. Now there is a particular order in which these particular aspects are being handled. So by default, the order is that the circuit breaker gets a higher priority over the retry mechanism. So now what we wanted to do was, we wanted the retry to happen first, basically the retry to handle this particular exception first, and then the circuit breaker picks up if the retry fails over, right? Now to do this, we have to change this particular order of the circuit breaker and the retry aspects that we have. So for this, let's go back to the properties here. Now in the properties section, remember I had commented this particular property, I'm going to enable this. What I'm going to set here is I'm going to set the circuit breaker aspect order as 1, and I'm going to set here a retry aspect order as 2. What does this mean is that the retry aspect has a higher priority over the circuit breaker because it has a higher value. So now with this, I'm going to restart the particular application. So the application has started now. So let's make a call now. Let me clear this and make a call now here back. So as you can see, it made 3 retries and then it returned the fallback value, right? Now, if you look here, the difference is 5 seconds and then 10 seconds. Okay. Now let's make a series of more 4 calls. Okay, so as you can see, I have made 5 calls here. It has retried 3 times for every attempt, and these are the 5 attempts: 1, 2, 3, 4 and 5 here, right? Now remember, I said like to activate this particular circuit breaker, you need to have a minimum number of 5 calls. So we have done those 5 calls. So this means that the circuit breaker is now open. Now the circuit breaker is only open for 1 minute, so I have to be quick now. So let me make a call here, and as you can see, it has not even made a call here. Let me try again. It has not made any calls. It's just right now returning me the fallback method. So let me try this again, and it's just returning me the fallback method. Now we will have to wait for actually 1 minute for this particular circuit breaker to move from the open state to the half open state. Now after waiting for the 1 minute, now we have moved to the half open state right now. Now when I made a particular call, it actually allowed the call to go through this time. So now let's make the next call. So here we can see the next set of retries. So this is the 2 calls that I have made after the circuit breaker moved from open to half open state. Now I'm going to make yet another call. Now if you see here, it has failed even for the 3 calls that I have made. Now because this has failed and we had set the permitted number of calls in the half open state as 3, we have made the 3 calls, and now the circuit breaker should go back to the open state. So let me make a call, and as you can see, it immediately returns me the fallback value. Let's look at it again, and the circuit breaker is still right now in the open state, and it's just returning me the fallback value. So today we saw how we can integrate the Resilience4J circuit breaker and retry mechanism. Now I keep on exploring such kind of technologies and solutions, so make sure you subscribe to this particular channel to see such kind of videos. Till then, take care and see you in my next one.